Welcome to this session about a company called Lightbend and their fast data platform. This is a company that created the programming language Scala. They've also been pioneers in defining the Reactive manifesto. They also support and have invented the technology Akka, which really lends itself to real-time analytics and streaming. We've gone from a world of batch-oriented analytics to live, real-time streaming analytics. And what's more important about their technology is that it supports up to millions of simultaneous consumers of this live streaming data. Lightbend is already working with some very important customers, and this platform has been operationalized on Azure and is running at scale. So what we're going to do is kind of review the main pillars of the technology, give you some live hands-on guidance on how to use it, and just simply walk through a bunch of important concepts that every developer ought to know with modern streaming applications. So for a long time now, we've been in a REST-based service world where HTTP is king and we're connecting up to these services. At the same time, there's been an explosion in data coming from sensors, devices, billions of users in some cases, and massive amounts of log files flowing out of applications. And so there's been a growing need really to combine these two worlds that are now overlapping at an exponential pace. And so what we're going to review in a moment is how we actually make this marriage possible and how these two worlds can work effectively together. Where do we see this market going? We see these two worlds colliding with significant overlap. And so the fast data platform from Lightbend is designed to meet this need. In other words, what we are seeing here is that these data workloads are no longer batch-oriented. Just as with microservices, this data streaming component needs to be long-running. It needs to be ongoing, and you need to have processes in place to be able to process it in real time. Interestingly, this means that data architects now must kind of consider data to be on the same plane as with microservices, in that these are long-running processes that must always be up with the same type of concerns we've always had, which would be resiliency, scale, and availability. So we just set things up for the future discussion here. So let's talk about microservices in some detail. Let's talk about streaming data in some detail, but let's really focus how Lightbend brings these two worlds together. So we just finished talking about these overlapping world of services and big data. This is the high-level perspective of the Lightbend fast data platform architecture. And let's start here on the left side where data might be flowing into the system. You'll notice, for example, in the upper left, some of that data might be coming across HTTP in a RESTful format. Well, in that case, you're going to probably leverage some type of microservices architecture to ingest that. On the other hand, data might be coming in the form of sockets or logs from devices and sensors, in which case Kafka might make the appropriate place to ingest the data. Let's talk briefly about the microservices you see in the upper left. You could think of that as a set of tools that helps you manage this data as either stateful or stateless. And you can also kind of consider it a form of middleware that is customizable depending on the use case. As we discussed, the Kafka can be thought of as an ingestion engine that has a persistent component. That persistent data gets consumed by the streaming components you see in the upper right. And there's a lot of good reasons you see for there, and that's essentially to provide you the flexibility to cover your most important use cases. You typically wouldn't use all four, but a subset of those four, depending on your need. Let's talk about some examples of how you might leverage the streaming components. You might be powering a real-time dashboard. That dashboard might be reflecting the scoring of anomalies for fraud detection or security. Think, for example, of suspicious IoT devices that have come online that may not be part of your network. On the lighter side, it might be a refrigerator telling you you're out of milk and would automatically order some. Or it might be some telemetry data coming out of an ICU, maybe streaming some heart information. It might be even some wearables data coming out of a device tracking the health of a patient. In the financial sector, it might be as easy as trying to quickly score someone's credit within just seconds instead of hours. As you can imagine, there's a wide range of use cases that's continually growing. Let's quickly define some of the pillars you see there in the streaming diagram in the upper right. Let's talk about the two places we see streaming here. We see it over here as a Kafka stream, and that's because essentially here we're reading and writing Kafka topics, perhaps for the purpose of cleaning data, storing last value aggregations, or maybe implementing K-tables for dashboards. Let's now talk about the upper box here on the right, the main streaming components here, and you see three main ones. You see Akka, Spark, and Flink. So when we talk about Akka streams, they're primarily here because they facilitate complex event handling scenarios. Now when we look at Spark and Flink, you can kind of think of Spark as a mini batch with a very rich feature set, and both of them, both Spark and Flink, deal with large volumes of data, but one might argue that Flink is really true streaming, offering the lower latency compared to Spark because it's not mini batch. Lightbend offers a very powerful management plane that really simplifies the management of these large and sometimes complex architectures. Some of the advanced capabilities include the capacity to auto-scale the cluster as needed depending on load, also to kind of tune things as they come up, whether or not that means increasing certain parameters, and also anomaly detection, looking for failures, looking for things that are out of band or extraordinary. Some of those capabilities are delivered through a combination of the intelligent management platform with Ops Clarity and DCOS, in addition to Lightbend's AI component in the upper right, which provides some of the machine learning aspects of this capability. And to round out this diagram, of course, you're going to need a persistent store, and Lightbend pretty much supports all the popular enterprise tooling here, whether that's SQL or NoSQL. You could be leveraging DocumentDB for JSON-based stores. You could be doing Postgres, MySQL, SQL database for your relational stores. It's actually up to the consumer to choose the most appropriate persistent store. So what can Lightbend do for you? Well, I think it provides value in three ways. One of the ways, of course, is to accelerate your on-ramping of this converging worlds we discussed. That is, of services and big data coming together. Number two, it comes with some expert guidance built into the platform to help you build your apps. So you really focus on the value proposition of your products, not on the underlying infrastructure. And finally, there's the AI-driven technology that lets you automatically manage this cluster, so you don't have to worry about scaling up, scaling down, finding flaws or anomalies in the system, and more. So in summary, these are the ways that the Lightbend platform provides value to its customers. So the call to action here is to go read more about the Reactive Manifesto at the following URL, and of course to learn more about the Fast Data platform at the Lightbend property. So that's it for now. More videos coming soon. Thanks for watching, and once again, if you need to reach me, you'll see my email there, bturkley@microsoft.com. I am Bruno Turkley. Thank you.